Awesome. Thanks very much for being here late in the afternoon. By Wednesday, I've been to this event 5 times. It's really tiring, both for attendees and for people that work here and presenting, so thanks for being here. And welcome to our code talk about Web3 agents. So today, what we're going to do is we're going to facilitate a technical session. We're going to show you some live code. We'll walk through the code, what it does, why we made some of the decisions we did about services and primitives that we use. And we'll also demonstrate and show you how the pieces fit together, how they work, and what the value of doing things this way would be. A couple things that I want to call out up front. You're going to hear a lot about Agent Core, which I'm sure you've heard a lot about this whole week. So both excited to share how we're using it with a Web3 flavor. So the takeaway from today is how you can use some of those primitives from Agent Core to build an agent that's capable of becoming a Web3 assistant. And then there are, of course, ways you can extend that for your own use cases, and we'll talk about some of those opportunities. The other thing is I want to talk about what that agent is going to be able to do and what sort of the run of show is going to look like. So this is sort of our general agenda for the day. A code talk, again, I mentioned it, walking through live code with you, talking about it. And we'll do some introductions of the different Amazon Bedrock Agent Core primitives where we introduce them in our code. But what are the requirements for this Web3 agent? So we thought about what some of the baseline needs someone would have to make an agent valuable for a Web3 customer, a user that's in the Web3 space, the Web3 enthusiast. First and foremost, it needs to have context from blockchain, so blockchain data, but also market, right? If you're interested in news, sentiment, prices, etc. So we want an agent that is able to go get that data that it needs to act on the prompts from the user. Secondly, it needs to have memory, right? It needs to be able to remember user preferences, be able to recall and search through previous conversations and state from previous conversations. So remembering facts about a person, what chains do you use, maybe what addresses do you have, even balances and things like that. So we want our agent to have memory, to be stateful. And then lastly, we also want our agent to be able to trigger or invoke other agents that specialize in a given task. So today we'll show you sort of a reference of an agent that can sign and broadcast transactions or get balance for a given address or wallet on chain. That's on Ethereum, right?
Yeah.
Yeah, on Ethereum. And so I think the last thing I want to say is this agent is not intended to be like a robo-advisor or to execute trades or trade intent. So I just want to call that out up front. Think of it as an assistant, not something that's going to make trades for you. And then lastly, I'm going to put a QR code up on the screen now so you can actually follow along. You can go to the repository. All the code that we're going to be using today is in here, as well as it's not a Jupyter notebook, but like a markdown file with all the steps that we're going to go through today. So if you wanted to go and run this yourself, dive a little deeper, we only have 60 minutes, so we can only talk about everything in so much detail. You can go ahead and do that. So with that, David, let's fire it up and switch views.
All right. So what we see here, this is actually the public GitHub repository that we are using today. And I switched to the workshop folder. And here we have basically the entire outline of the session, what we're planning to do today. So you can actually also look into it, and there's like a technical explanation for every single step enlisted here. Back to Forrest.
Yeah, absolutely. So I think the first, the preliminary setup that we're going to have at the beginning, the first bit of code that David's going to walk through is a baseline agent that's going to be capable of searching the web and capable of adopting memory, so creating long-term memory using Agent Core memory. We're going to deploy that agent using Agent Core runtime. I think one of the most important things that I want to call out for Agent Core runtime, obviously, it's an environment where you can deploy and operate your agents, and I think that's very clear. But one of the things that I want to call out about Agent Core runtime that's particularly important, I think, for use cases like this related to Web3 is session isolation. So when you run an agent session, you invoke an agent with its session ID, it creates its own micro VM with isolated compute, memory, and file system for storage. So if you think about, let's say, an agent that helps users process transaction history to generate an opinion for cryptocurrency taxes, for example, you don't want sessions being mixed between different users where they're pushing really sensitive information like transaction history, XPub, public keys, addresses, et cetera. All of those things you want to make sure are isolated and kept separated from other users. And so that's one thing I wanted to call out about Agent Core runtime, and something to keep in the back of your mind as we talk about, or we start doing the deployment. You want to move to the architecture, David? And so this is sort of the end state of where we're going to get for like the part that we build with you here. There are some other components that it'll interact with. I think there's another architecture diagram later that we can show you. But generally speaking, this is where we're going to land at the end of the session today. Obviously, we're using Agent Core Runtime, which I just mentioned, and we're using the Strands Agents SDK, but you could execute this sort of the same setup with any other agent framework that you prefer. So we chose Strands, but you could choose something else like LangChain, for example. We're also going to be utilizing observability for logging. We're also going to be using a browser tool, the Agent Core browser tool, to get access to some of that data that we want. So from things like block explorers. So David, let's maybe start with the first round of work.
All right. So we also want to call out that this session is really intended to be interactive. So if you have questions, if you want to do like a deep dive into certain things, please don't hesitate, ask us. There's a lot of content here for certain things, as Forrest said, like we will use like Bedrock, we will use the memory part. You probably have seen some of that stuff already in other like workshops. We are using it, but we want to actually also get to the end for like the Web3 specifics here. So we will not spend like too much time on like the Bedrock Agent Core part. We will not spend too much time on the memory, how that works, the hooks. We will call out the most important things. But if you feel that you want to have like certain things a bit or a bit more explanation on certain things, please ask us, because we do not really have too much time here. We are like with roughly 50 minutes left. So, and then also afterwards, if you have questions, we are outside. Please do not hesitate. Reach out to us, talk to us, connect with us, or look into the repository. All right. So with having that said, this particular folder or like this particular workshop that I'm showing, we have like all the code examples in here. These particular code examples are also in a code folder that I will be using today. So this is basically the folder that you're seeing over here. And what we will do is we are using like a Docker-based approach, so something that is actually really close to production. So we are assuming like, okay, you have like an agent that you want to build. We're using like a Docker build process. We're pushing it to ECR, basically like the container repository, and we are actually fetching it from there. So you will see this. And this is actually because it is really like more like closer to production instead of using like any of the wrapping tools or like bootstrapping tools for this. All right. Also, there in our, if you're following through on your own machine, there are a certain set of policies required in the IAM policy, for example, for a CLI to deploy these things, pointing it out. For sure, you need like a couple of Bedrock and Bedrock Agent Core requirements, but we have these things actually listed in the README or in the workshop file here as well. All right, so the first module is actually now, we will now create like a base Strands agent using like with memory support basically. To do that, we have like UV in it. So UV is like a Python, like a next generation Python package manager, and like the README or this particular workshop file explains how you set up everything, how you're creating it. You run UV init, you run UV env, and then add like Boto3, the Python dependencies, Bedrock Agent Core, and Boto Core. As you see on the screen here, we have the UV log, and we have like already like this file. Basically, the code folder has been initialized as like a UV project, so I can now run UV or like use UV run to run our commands. That basically means we have like all the requirements, like all the dependencies, the Python dependencies in the folder. Also what I did is like, I venved it, so I have like my venv folder here with UV venv, so you could actually even source it from there. What I did is, or what we did is, we have like the UV basically, or in this folder we have like the base requirements to run like the scripts later on, for example, the deployment or the agent called create. So the Boto3, the Python dependencies are in this folder, and we have like a dedicated requirements.txt in here. This particular requirements.txt basically points out like all the requirements, all the Python requirements for our strands agent. And I don't want to go too deep into these things. We have like strands agent core, the core dependencies. Playwright is one of these browser supported or browser related tools that we'll have in the that we need in the one of the build out steps for the strands agent when we're using the browser. And we will use Boto3 later to invoke another agent. So there's some sort of like an A2A basically that we're looking here to do as well. Also what I want to point out, there is like another stack. So we have the overarching repository that we are looking into here. It's called Crypto AI Agents. There's like another cryptographic, like a crypto agent in place that I already pre-deployed. These requirements, the sources and all these things, they are all in the repository. So it's everything in the repository, but like what I did in this particular account, I already pre-deployed the Crypto AI agent because this is a bit more effort, and I'm actually gonna invoke it or integrate our strands agent with that Crypto AI agent later on. But we will actually talk about that in more detail when we are at the last build-out step. All right. So the first agent that we are creating is basically, as I mentioned before, we have like a couple of core dependencies. There is create agent. There's the memory client that we are using over here. Give me one sec. Yeah. Just to create the core memory, because like strands or like Bedrock Agent Core supports memory, and memory is like a core functionality if we are building out a Web3 related agent, because we need to explain like a couple of things. We need to tell it like, okay, what are we interested in? Is there like a specific coin? Is there a specific role that I'm having? So we need some sort of like long-term memory. And this particular long-term memory, we are setting this up before. There is a script called create web3 agent memory.py. We can run this, and we have a couple of different memory strategies defined in here that are being used later on.
I can talk a little more about the memory strategies. So when we were designing this and working on this, we started researching how you'd go about building agent memory from scratch. So how would you go about doing this if you were to set this up yourself without using Agent Core? It's relatively straightforward to use open source tooling to create memory, put raw data somewhere, and give your agent access to that. And when we started doing a little bit more research on how you would actually utilize this in a practical sense, we started testing it with Agent Core memory. So just a couple of things about how this works. One, Agent Core memory has the short-term memory, which is raw data. So basically, as events get created by your agent, those get stored as raw data in a short-term data store for short-term memory. If you enable long-term memory, and you have memory strategies for things like summarization, semantic search from previous state, or user preferences, there's an asynchronous automatic process that pulls events from that raw storage short-term memory and creates vector embeddings for it and stores it in a vector store for long-term memory. You can configure how long the time to live is for that data, so how long the data will persist. And I believe that the time scale for that is a year that you can extend it to. Default is 7 days. That's what we're using here. I think the real value is in this piece here that you see on the screen. So the pre-built memory strategies for long-term memory, because it cuts down a lot of the complexity and the time it takes to build a vector store-based approach for, especially for things like semantic search and summaries of previous conversations that you have. And so when we start demonstrating this agent, you'll see it remembers some of the previous conversation that we've had with it, or I guess that David's had with it.
Yep. All right, so we have like a memory, so a database basically in place. The next step, and this, again, the workshop guide asks you to create this Web3 agent.memory, and you see like, okay, I already have like my file in here, so I actually have these things copied over. And the next thing that we need to do is for sure, okay, we need to tell like our entire infrastructure, okay, where do we want to deploy this? AWS account ID. And, oops, I already have my account set up that I want to deploy it into. All right, there we go. Now, when you're running this on your own, what you need to do is basically UV run web agent memory.py, and this will actually return like a memory ID. This memory ID is very important. We will remember and we will use this later on. I already did or created this particular one. We will see we will see this memory ID actually later on again, but I have it in an environment variable now in my terminal right now. Also to be a bit faster with like, or to quickly go over what, like how we do like the memory integration, the next thing is that we have like a memory.py file, which will automatically be added to the Docker file as well. Memory.py is basically just like a helper module that we will use for our strengths agent. Memory.py has like in this class, this long-term memory hooks provider that we have defined for our agent here. This is the constructor. We're passing like the memory ID over to it later on so that we know like which particular memory store to talk to. We have the function with retrieve user context. We have save conversation. And then basically we have the register hook so that every time like the user, our Web3 analyst or the Web3 person, every time we are interacting with the agent, that the agent basically is like these hooks are being triggered and that we are actually saving this information in like a long-term memory. All right. So this is basically in memory.py. Again, here I have like everything in like my memory file. Oops. The next thing to build or like build out like a base Web3 agent, we have something called the strengths agent streaming memory. We have a file that, or like we have this particular strengths agent. Strengths agent, you might have seen it already or probably have seen it already. You have participated in another session here at reInvent. If not, we will just quickly walk over through it. We using like async IO for non-blocking interaction. We have like import the strengths, the agent, and the tool. Tool we will use for later for our tool integration, like of the crypto AI agent stack. And then we are actually importing like memory client from Bedrock agent core memory. And this particular import that you're seeing here, this is basically where we import the long-term memory hooks from our memory file that we have previously created. And besides that, everything is basically like a standard agent. We have a hard-coded user ID here right now for our demo. And what we did is like we have like a little tool. This is basically just like get version, so that we know like which particular agent we are interacting with in case that something goes wrong with the deployment. And then we have the system prompt, which is basically now specifying the Web3 user requirements. You want to mention a few things about that?
Yeah, so we've created a handful of different types of agents, some that are a little more specialized, some that are more general in nature. Obviously, this one is more general. But I think that system prompt is one of the best places for helping specialize that agent for a specific task. So I think I recognize a couple of faces from the session we had, I think it was like an hour and a half ago, about blockchain data. So we had a blockchain data analyst agent. And so in the system prompt there, we provided a bunch of tips, best practices, and patterns for how blockchain data is stored and queried. And again, for an assistant, this is a place where as you test this agent incrementally, you would add additional like steering here for which tools to use based on which prompts, what data, like also for memory, you can also kind of give the agent autonomy in determining what should be stored in memory and what shouldn't be. So what we have here is relatively simple. We'll add to it sort of throughout the session. But again, this is a place you can customize your agent a lot.
All right. Down here we see we have like our memory hooks integrated with the hooks provider, and we have the tool where we are actually just passing like the get version right now. And last but not least, for our model, we are providing this like as an environment variable. We actually will talk about this in the next step with the Docker, but we're using Cloud Sonnet for this, so that we are actually know like which like inference or which model, which LLM we are using for this. Last but not least, there is in Strands we have this app entry point, basically the agent invocation. And what we do is we have like a stream agent, a stream sync, so that basically means as we do not wait for like the LLM or for the full response to be created, we are streaming everything back. You will see this in our client now, so we thought like, okay, like an interactive, like a streaming client is like, it's a bit more interactive for a session like that. Also what you can see here is basically these are just like a couple of debug statements. If you want to get some more information about tool use, about the reasoning of the model, you could actually uncomment this, and then you will actually see like how the model reasons about certain tools and returns like these things in the stream as well. But this we will not do today because that would actually be very noisy. And it's really good for debugging, but not that good for our thing. So this particular agent that I have now shown is living in Strands agent streaming memory.py. We have this exactly over here. So we're almost done. So we have like a Strands agent defined. We have like memory set up. As I mentioned, the memory, I ran this before. The memory, the database creation takes a couple of minutes. So we have like a memory in place already. And I have like this memory ID. You will see it later on. Now, to build everything, so we need like Docker for this, and we can actually see like, okay, Docker PS, Docker -- version. We see, okay, we have Docker installed. There is no specific requirement. It is just that we're using a Docker-based build, so you need to have Docker on your machine, or you need to have like some remote Docker or like remote build engine somewhere. Now let's have a quick look on how we can integrate and how we can deploy our agent. Again, we are using Docker, so what is like required for Docker? Okay, or like a container, we require like a Docker file. Here we have our Docker file listed. It's very simple in this case. We're using like a Python base image. We are copying and installing like the requirements. These are the requirements that we defined in the beginning. So these are basically just the Strands agent requirements, where we have the browser integration and where we have the Boto3. Then we also install like an open telemetry distro in this particular Docker image or in the Docker container. This is really so that we can separate like the operational piece from the application. So that is just that we are doing that over here. Then we are setting the AWS region where we want to deploy it. We are setting up the inference profile. This is like the cross-region inference profile that we're using for Cloud Sonnet over here. How can we see this? This is now actually like cross-region for the US. You will see, so we are deploying our agent in EU, so it's running in Frankfurt. You will see like the changes in a moment. And then last but not least, we have our memory ID that we are also passing into the Docker container. And a lot of these things today are really like just optimized for the demo. Like this is basically like why we're passing the parameters in that way. Now, if we just have like a quick look on how this, what is different in my Docker file over here, we see instead of like the US East 1, we have EU Central. Instead of the US cross-region profile, we're using EU. And then basically, we have like already the memory is already in there. And then for the later agent, we have like a couple of like references for the other agent, but we will talk about this in the next step. All right. So what is the base requirement to build like such a Docker or like such an agent? Base requirement is that we have a repository. I created a repository, but if you're running this code, you will actually get like your ECR repository back. And then you basically just need to log in into this. And again, like if this is too fast or something, because we need to explain like how you're actually building up the infrastructure. If you have questions, please do not hesitate. But otherwise, yeah.
You said what's the architecture for the Docker container? Correct. The required architecture is ARM64. In like for example, if you were doing this in an environment where you're using AMD, you can use Docker buildx to do cross-platform build. But the expectation is ARM64.
So you see exactly this is what we're doing here. We are using the buildx because ARM64 is target basically. No big deal on like a mega machine. Like if you're doing this like on an x86, you need to have like some sort of like a cross compile there.
In fact, if you're building this on Cloud Shell, you'll run into this issue because the architecture is different.
All right. So now what I will do is I will make sure that like I have like the most recent credentials in here, and then we're triggering the buildx basically, and then we are pushing it up to our repository. This is basically what is everything that is integrated in this command. Docker buildx build. We have like our platform specified, and then we have like our target repository in here, as you see, and then we're pushing it. Okay, we credentials, Docker is going through, okay. There we go. Perfect. So now we have like our strands agent, and we have pushed it to the ECR repository. Now there is also one more, like there's, as you know, like you cannot do anything on AWS without proper IAM policies. So we have like another step that is required for the deployment. There's a create agent runtime role. This is like the runtime or the IAM policy required for our agent core, Bedrock agent core. Here we have like the invoke model defined. We have like the ECR permissions and all these things. And if you're running this, you will get this particular agent core execution role. And in this particular workshop or like in the file, we will actually like iteratively add like more permissions so that like with more features, we are always adding like additional IAM permissions so that we have like that we follow the least privilege policy as well.
We have a least privilege IAM role in a folder in the repo now.
All right, so then there's also like deploy agent. Deploy agent is like a small Python script, a Python helper that created for this. This basically is just using like Bodo 3 Bedrock agent core control, and then says like client create agent runtime. This particular client create agent runtime creates like a new Bedrock agent core runtime that we will then use. And what we do, we are pointing that particular runtime towards our ECR repository. This is our repository so that runtime knows, okay, we are always pulling like our containers from this particular repository. And we are passing like the IAM policy to it. This is what we see here. The role arm is basically our Web3 agent core execution role. If you run the deployment, you will then see, okay, agent core runtime created successfully, runtime arm. Because I created it, and we will actually come to this later, what I will do instead, I will not run create, I will run like another script, which is actually, update agent. Because I had these things pre-deployed. If you have no Bedrock agent core environment, you just like run the create one, otherwise you run update. All right. Now, we are getting back like the agent runtime arm, and this particular runtime arm we are putting into like an agent runtime into like an environment variable. This one is basically This is our runtime, like the agent core runtime ARN that we are using. Now we are using like an invoke agent async file. So this is also like, we have like a small terminal in here, like a streaming client that we can now interact with this particular, Bedrock agent. This file is called invoke agent async, and this is actually now what we can use to interact with our agent. And this particular terminal, or this particular streaming terminal basically for our interact with our agent, is basically sourcing this agent runtime ARN. So this is like how it knows what particular strands agent to talk to. Then you copy this particular one also in your file, and then we go and interact with our agent for the first time. So this is again like UV run invoke agent async. Okay, this is like a random session ID that we are creating every time. And so how are we doing? Let's see like if our agent is responding. All right. So now, as you see, I've like set things up a bit, like to speed up the process. It kind of remembers, I told it like my name is David. So, hi David, based on our previous conversation, I told it that I was interested in some of like the crypto-related things. Okay, it remembers that. And that now it's actually recalling the previous conversations. So now it knows, what does it know in the Web3 space about me? Let's see. It knows something about Bitcoin and Ethereum. And now we can actually also tell it, oh, for future conversations, please also include. Is there like a preference? Solana? Okay. So this is actually now how we are building up our preference. Okay, there we go. And what we have seen now, it has already updated like our portfolio focus. Now we, like every time we're interacting with it, it will also return like everything from Solana.
Yes.
I see in the environment you are using the blockchain RPC URL and you are connecting to Polygon network. Is that accurate?
No, so what you're referring to is basically this other, we will get into this, like this is the other stack that you're referring to. There is a default parameter like for the Polygon RPC, but you can update the RPC endpoint. But the RPC endpoint is like then again like just required if you're doing like a direct interaction with the blockchain itself. If you're, for example, asking for a specific account, like a balance of an account or like certain things. We are like more on a high level right now. We are not yet interacting with this because like this RPC endpoint is really like the other stack, the other agent that it requires.
So for like the portfolio focus, like do you have like a single place where the memory is, or do you have like, okay, I have some memory about like this is like the portfolio focus, this is the stuff that I should be including in my outputs, and then this is user information over here in this place. Like, should we like be splitting up our memory into multiple kind of focuses, or just kind of keep it all together and let the model figure it out?
Yeah. So there are options there. So the built-in strategies and the memory hooks will usually use reasoning to determine what needs to be stored and where. In terms of like from a user ID and session ID perspective, the memory is namespaced and encrypted, so it's also kept separate. Otherwise, it would defeat the purpose of session isolation at the runtime layer. But there's also the option to do custom strategies that extend the default behavior of some of these default strategies that we showed. And then there you can sort of predefine what types of insights need to be stored where, stored together. And obviously this is even more helpful in long-term memory from a vector embeddings perspective. So you have either the more out-of-the-box method or a more custom method.
And is the custom method, is it basically just natural language, like tell whatever agent is doing the evaluation about where it needs to go?
Yes, there are ways to do it in natural language, but then there's also ways to do it logically when you set up your memory, the memory provider and memory hooks. Yeah, absolutely. And this stuff is documented, and I can get with you after and show you the documentation for it. Any other questions we can answer while we're at like a stopping point? Yeah.
How would you be able to distinguish between like different customers? Like
Yeah.
different customers might have different preferences. I want Aptos and the other one might want so on.
Precisely, yeah. So when David was briefly showed the Docker file, I think it was, he has defined in there a user ID. Like in a production agent where you have many users, you would have obviously dynamic user IDs. You might be tying into identity platform. You have OAuth, for example. We have user IDs. And then each session that's opened would first check the user ID, and then that's what you would namespace memory for. So you would have all of your user memory separated, and then that would resolve that issue, right? So each user has its own preferences, it has its own conversation history, list of previous sessions, et cetera. So great question, and yeah, for the sake of this demo, we wanted to simplify it, but in reality, in production, you would have everyone with different user IDs, and that's how you would resolve that. Yes?
Can the memory be queried separately once it's built?
Sorry, could you repeat?
Can the memory be queried like separately once it's built? Like by Aptos?
You know, that's a good question. I don't know the answer to that. I don't want to tell you the wrong thing, but I will get you an answer if the memory is queryable separately. I know you can access it from multiple agents, but I don't know if you can do it from some other client directly. Any other questions before we move on to the sort of the next version of this agent? We build in some incremental features on top. Awesome.
All right.
David, one thing before you jump in, I also want to I wanted to call out to the sort of like the build process and the iterative nature of it. So the build process generally remains the same, right? You change code in your agent, you build a Docker image, you push it to ECR, and then you either create a net new or you update your agent. So really compatible with CI/CD processes, et cetera. But also Agent Core Runtime works really well with this sort of pattern because it supports versioning. And so as you create new versions of an existing agent by name, it will point the endpoint for that agent to the latest version, but you also have control over this. So you can start to separate multiple versions of agents with different endpoints, so you can separate environments, so you can do development, staging, and prod, each with a different version of your agent code, or you can start to diverge the behavior of those agents and separate them by endpoints as well. So you have a lot of control over this. The default behavior is handled for you, obviously, which is just directing the invocation endpoint to the latest version, but you can control that either via API or from the console.
All right, yes. So now let's talk about the next browser. Sorry.
The next browser.
No, about the next iteration. So what we will do now is actually use like add like browser use or like browser access to the agent. Because if we want to have like an agent that is supposed to somehow like query like current information, there is always a way, okay, we can go to like some predefined REST APIs, for example. There are like plenty of REST APIs out there that provide like market information. But I mean, there are other pages, web pages that provide a lot of information, sentiment analysis and all these things like basically directly for free. The data is unstructured. Usually the other APIs, they are like super structured. They provide like proper JSON. That again like is a lot of work like to integrate. So we thought like, okay, for Web3, let's use some browser related things as well. Also, just to follow the process, as I mentioned before, like you always have to increase IAM permissions. So what we will do, or what I did is actually for the policy, there's the script that actually allows us now to use like the Agent Core browser feature. So it adds like all the permissions required for the browser access. And you copy this particular file to your file system and then you run it basically. And every time you run it, you will get like your Agent Core execution policy basically updated. So I did this before so that we can actually save a bit of time here. Now we are looking at the Strands agent. Browser use is basically being added in here. We have like Playwright, and we have like Bedrock Agent Core Tools browser client that we will see. And if you log in the console, you will also like see browser sessions coming up. Besides that, we have a tool defined now for our Bedrock agent, for our Strands agent. This tool is called getCoinData. Sig was Playwright, and we have like a tool called getCoinData with browser. This is calling this method, and this method is then basically where we define, okay, with browser session, we're passing the region and all this information into it. Region is being sourced from environment variable. And what it basically does is, okay, we want to use CoinMarketCap in this case. And we want to just go to CoinMarketCap and get like the coin-specific information and then basically process it. Then we basically consume this data in the LLM and we analyze it and then hope that like it provides like good information for us. And that's basically what we have here. Now I will exit this particular, and you see I have my Strands agents memory browser .py. I have this file in here. And what we can now do is like vim, let's like the Docker. Oops. I can do this now with the Docker file because the Docker file includes the entire directory, like all the files. And I'm just basically telling like my process in the Docker, like which particular tool or which particular Strands agent version to call. That's why I can just type in the browser and it gets automatically. So what I do now is like I just do the Docker build X. So we're basically building the next version now. Now this particular Docker file is using like the browser-enabled Strands agent. And we are running the UV run update agent. So basically we're pulling like the latest, we are telling it to use the latest Docker version for our Strands agent.
While we wait, the browser tool that we're using here is the one that's available in Agent Core. So it's a built-in tool that's available through Agent Core. It's a headless browser that allows you to automate a lot of different browser tasks. Here we're using it to get coin data instead of using a structured set of APIs because it allows us to get a broader set of data more easily. It's also something you could use pretty readily for doing some general sentiment analysis by pulling from news syndication websites and other things like that, which we did test when we were building this.
All right. So this is why I just added like this tiny little version thing. So I wanted to see like what version it is. In this case, it is now the agent with memory and browser. And okay, let's provide, and we see provide some market data for my crypto. Oops. Okay.
It'll figure it out.
Yeah, it will figure it out. So now it should actually use the browser, figure these, use like Solana, Ethereum, and Bitcoin, query the data, and then provide like some analysis. Okay, awesome. Oh wow, there it seems like there's something happening at Ethereum today. So okay, now we have like a Web3 agent that is actually able to interact with the browser with unstructured data and all these things. Now, this is basically on the data gathering side. Now, to have like a browser or like an agent that is really able to interact with the blockchain itself, we have to add like a bit more complexity. To do so,
Yeah, sorry, I missed you.
Is there an easy way to see like all of the tool calls that it's doing or all the browser interactions that it's doing behind the scenes?
Yeah, so
we could actually enable the debug flags for this.
Yeah.
This would be exactly these things that I pointed out. I have not enabled them, but this is, for example, up here. It was up here. Yeah.
Right there, yeah.
They would actually tell you like the reasoning about like what tool to use and when to call what. Because I mean, this is really important. And like with agents, when you need to really be specific with the system prompt and do the routing and tell it exactly what to call, because otherwise it might just get confused and starts to hallucinate, right? With like, oh yeah, I have this information or something. So it's like having these hooks in here, and I'm calling out this information that is really helpful for that. Mm-hmm. Yeah. All right, so we have like roughly 15 minutes left. And, all right. Yeah, so what we have done now is like our agent is interacting with like can now interact with like, for example, any coin-related market data, like crypto-related web page. The beauty of that is it gets like all these data points now, right? It gets the market, the volume, it gets sentiment and all these things. It can actually extract everything from these pages directly without me having to collect like or connect to whatever like 30 different REST endpoints and do Twitter feeds and all these things. I mean, yeah. All right, now.
Yeah, so then the last step here, we alluded to it at the beginning, the last step is allowing this agent to invoke other agents that specialize in a given task. And so the task we wanted to show you here is connecting to an agent that can actually interact with the blockchain directly. And so an agent that can leverage the key management service, so KMS, to sign a transaction and broadcast it, or just simply made read requests, like RPC requests to chain. This diagram that you see here is from actually an architecture that a colleague of ours built, and we sort of tacked on top of this for the sake of this workshop, so we could show multiple agents working together to do something. And in this, he had some news source knowledge bases, a data analyst agent, and then access as well through tool calls to a crypto price API. And then lastly, a tool call for accessing the chain directly. So we're gonna, David's gonna show you the latter, right? Interacting with the chain.
Yeah. All right, and you see this particular stack. This is the CDK that is actually also included in this crypto agents with Bedrock. So you can actually deploy it with CDK, and then there is actually also like a couple of like blockchain-related things like RPC endpoints, and these are required for this stack now. And we will actually now integrate with this particular stack and then see what we can do with that. All right. Again, it's as important. I mean, I pre-deployed it because that would take a bit too much time, particularly because of like knowledge bases and all these things. And what I did as well is we actually updated our IAM policies because we need to have like additional, we need to have like a Bedrock invoke agent permission for this. And then yes. All right, now we are looking at our strands agent again. And how do we actually update it for like the A2A use, or like how can we now integrate it with like the other crypto stack? That is fairly straightforward here. We are using Bodo 3 for that, and we have like our own tool definition again. And this is really like, we are just calling, we're doing like a Bedrock agent runtime client, invoke agent, and we are then having like agent ID, agent alias ID. And that basically tells like our strands agent to invoke, use that tool. That tool will then actually interact with our Bedrock agent. Again, we have like our tool definition here, and now it is really crucial that we are also updating our system prompt and do basically like the proper routing here, right? So we need to tell it, okay, so we have like invoke Bedrock agent, and what is this everything that is, for example, for wallet operations, send, check balances, please reach out to it. This particular other stack has like also some data feed gathering, so we can also use this particular agent for cryptocurrency price fetching and all these things. And we have like a couple of examples in here. So for example, if I want to check my account balance, and we're talking about like an account that I created or like an account on a Serum Sepolia testnet, then it will actually invoke this tool. Besides that, not much has changed, but I removed the browser because like we're just like going from tool to tool here. And all right. This particular file is located in the A2A. So to do So instead of browser, I'm now using A2A. And we will now trigger this entire build and update pipeline again. And as I mentioned before, and you have seen that in the Docker file, the agent ID and the agent alias ID, these are in the Docker file already, so this is pre-configured. All right, it's updating. So let's see what it's doing. Invoke agent runtime, so takes a bit till the first response. I don't even know what the specific version was. It's an, okay. So this other stack now has like a KMS key associated. A KMS is like the Amazon key management system. And KMS allows us to manage like private keys as well, or like it's primarily for key management, so private keys. The beauty of KMS is here that we can actually also directly integrate it with like or use KMS to sign EVM transactions, SECP 256K1 particularly. So like everything with this elliptic curve, we can use the,
Wouldn't be a live demo without the service unavailable exception.
Okay, I think I got
probably
throttled.
if you rerun it, it'll chat with it again, it'll work.
Got really it's throttled, okay, or something. But yeah, we are live. I mean, these things can happen. But yeah, as I said, let's see. Oh, okay, now there we go. So with KMS, what we can do is actually we can now sign blockchain transaction. And is everybody familiar with like how like wallets work on Ethereum, for example, or like public keys? So it is important, like on like a blockchain like Ethereum, like the accounts or like wallets. Like these are like basically identified by, or balances like associated with like a public address. And the public address is basically like this is the public key, the public key of like a certain private and public key pair. And when we are using like KMS, we can actually extract the public key and then we have like a bit of like calculation. But basically we can actually use the public key from a KMS-based private public key pair for Ethereum, for example. And I'm not even sure if this is the right way to ask for it. That is okay. So while we're waiting for the response here, otherwise I have to do like another. Okay, this is the wallet address. And I will actually go in detail like now what happened in the but we will first of all check, okay, what is what balance do we have on our account? So yeah, it's now interacting with the other agent, and then basically reaching out to the RPC endpoint. Okay, that looks correct. Oh, that's but how do we validate that? So we're taking this particular address, and we go here, and this is now for everybody who has never seen, this is the Sepolia Blog Explorer. And I'm typing this one in, and oh wow, so it seems like someone funded this particular address with some Sepolia testes. Awesome. Now, how do these things work? So, if you're interested in this, like what happens is basically, in the other, we have like the crypto AI agent supervisor stack. We have a Lambda function. Everything is in the index py. And we have a couple of different functions and methods in here. And I can really, if you're interested in this, I wrote like a few blog posts about like how you can use KMS for Ethereum, particularly with different type of like signature standards, EIP 155 and 4337, for example, for like different transaction types. But like the way how you would usually do that, or like how you can actually first of all map like a KMS key or like a KMS public key, because you do not have access to the private key. KMS is really like you create a private key, it remains inside the HSM. It cannot be exported. You can import a key, like you can, for example, use import like your MetaMask key into KMS, but you cannot export it. That's basically the idea. It's a fully managed blockchain, like a fully managed key management service. And fully managed means like the backups and everything, AWS takes care of that. And the security to permissions, that's basically what you would do with IAM. Now, as I mentioned, like you have to do a little bit of calculation to extract or like to do the mapping of like a public key on KMS to like a public address on Ethereum, for example. Here we have a method, there's calc Ethereum, and we are passing like the public key. This is the byte representation of the public key. And then if you look into like how keys are being handled inside like HSMs, there's usually something like ASN notion. So you basically need to decode some of these things. And what we have here, we are actually, the information that we are looking for is basically the subject private key. And this is what is happening here. We have like the subject ASN, key definition, and these things are all like defined in IEEE, so certain standards on this. We are then actually extracting the public key, and we are doing a bit of like merging or like calculation. So we're taking the bytes, we are actually just taking the last 40 of the hex address, and then we can turn this particular public key that we calculate into like a checksum address. An Ethereum checksum address is basically identified for everybody who is not aware of this, like the upper and the lower case in the public key. Basically, this is like the checksum. This is actually how you can validate like if an Ethereum public key, like if you want to send something, you can validate if this is a valid address or not, or if something is missing. And yes, this is basically now integrating, providing all the functionality for us. And this is actually important when we are doing this get wallet address. The other client, the other agent is actually just like instantiating like a Boto3 client with KMS, and it's basically downloading the public key. And the public key is then like basically recalculated, and this is then turned into our public key address. And in the same way that we are just having like, in the same way that we are basically mapping like an KMS public key on like an Ethereum wallet or on an Ethereum, like an Ethereum account, you would say like an Ethereum EOA, like an externally owned account. In the same way, we can now also do a bit of like magic for signatures. So we can use KMS to create signatures for blockchain transactions. Basically, what you would do is you pre-calculate you set like the Ethereum, the EVM transaction, you take the hash value, you sign this hash basically with KMS, and then you decode it into its different components for EVM, it would usually be RS and V. So you have like these 3 different parameters that are being validated. This is actually also, everything is encapsulated or everything is written down in this index.py. All right, and now what this basically allows us to do is, like from our agent, we can actually query our account balance. We can also go and like check like the account balance of other accounts if we want to, or we can ask it to send certain funds from our blockchain wallet to, for example, to someone you want to send like the ETH funds to or something else.
So I think we're at time now. We covered a lot of ground like we wanted to, and we ended up landing on the other agent functionality that we had hoped we'd get to. So really appreciate your time. If you have questions about anything that we didn't get questions on during the session, we'll stick around right outside the door. Feel free to come introduce yourself to us, ask us any questions that you have, and again, enjoy the rest of the conference and have a great rest of your evening. Thank you.
All right.